Okay, Assalamualaikum. We are from Group 3. We will present for subject Thermofluid. In this video, we will present about steady flow engineering device, which is our device is turbine. We hope that all our below friends can gain something from this video. And if you have any question, feel free to ask at the comment below and we will try to answer it. For the first presenter will be me, Muhammad Amir Amin bin Mazalan. Secondly is my partner, Tengku Muhammad Farid Daniel bin Ismail. And lastly will be Megat Faiz bin Megat Zaini. Okay, Bismillahirrahmanirrahim. My name is Muhammad Amir Amin bin Mazalan and I'm as the first presenter. This is all the part that I will present. The first one is introduction. Next is definition. Third one is physical feature. The fourth one is turbine versus compressor. And the last one is turbine operational. Okay, for the introduction, a turbine is a device that harnesses the kinetic energy of some fluid, such as water, steam, air, or combustion gases, and turn this into the rotational motion of the device itself. Turbines are generally used in electrical generation, engine, and propulsion system. A turbine is a rotary steady-state, steady-flow machine whose purpose is the production of shaft power at the expense of the pressure of the working fluid. So, steady words indicate that there will not be any changes with respect to time, and we will see the opposite of steady, then that will be termed as unsteady or transient. When we talk about steady flow, then we must understand here that we are talking about constant flow rate of mass and energy throughout the control volume with respect to time. We can also say that the rate of flow of mass and energy throughout the control volume will be constant with respect to time. Okay, for the definition, what I can explain is that turbine drive the electric generator in steam, gas, or hydroelectric power plant. As the fluid pass through the turbine, work is done against the blade, which are attached to the shaft. As the result, the shaft rotates and the turbine produces work. For the physical feature of the turbine, turbine is the device in which fluid expands. During the expansion work will be done by the fluid to the drive, for example, electrical generation. In this case, power output occur. So as you can see in this picture at the inlet, initially at the inlet, pressure and temperature enter, and then when they exit at the outlet, pressure and temperature both will be smaller than the pressure and temperature at the inlet before this. There are several common assumptions that are made in the energy analysis of turbine and compressor. If there is no intentional cooling, the heat transfer for this device is more relative to the shaft work. The work term is important for all these devices. For turbine, it is the power output. For the compressor or pump, it is the power input. The fluid velocity in turbine are high and the fluid experience a significant change in kinetic energy. However, it is small relative to the change of enthalpy. The velocities involved in compressor and pump are too low to cause any significant change in kinetic energy. The potential energy change of the fluid passing through the turbines, compressor, pump are small and are neglected. For the turbine operational, turbines are steady flow engineering devices that are rely on shaft work to drive an electrical generator. They are found in steam, gas, hydrostatic power plant. Heat transfer is negligible. In addition, potential energy is negligible unless otherwise stated. Finally, even though kinetic energy is present within the system, the change in enthalpy is normal much greater. As a result, kinetic energy also negligible. During operational, superheated steam will be pushed through the turbine. As this is occurring, it is possible that the steam could become saturated gas when it leaves. This must be taken into consideration when you are calculating the exit enthalpy. Finally, liquid can damage the blade. Liquid can damage the blade of the turbine. As a result, it is best to keep a fluid in a gas state as it passes through the turbine.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Farid and I will continue the presentation about steady flow application in turbine. So in this slide, I will brief some introduction of steady flow, and after that we will analyze the steady flow energy for turbine. For steady flow process, net quantity of energy contained within the system will never change with respect to time. Therefore, according to the principle of conservation of energy, we will have following statement and energy equation for a steady flow process. Net quantity of energy entering to the control volume equal to net quantity of energy leaving the control volume. I will repeat again. Net quantity of energy entering to the control volume equal to net quantity of energy leaving the control volume. Now, let us come to the point which is steady flow energy for a turbine. Turbine is basically defined as one prime mover where the thermal energy of the high pressure fluid will be converted into mechanical energy in terms of rotation of turbine shaft. Mechanical energy developed by turbine will be finally converted into electrical energy. Turbine is also designed as mechanical device that will provide the work energy through the expansion of fluid. Let us see here the following figure where high pressure fluid enters at inlet 1-1 and low pressure fluid leaves the turbine at its outlet section at 2-2. I will repeat this again. Where high pressure fluid enters at inlet 1-1 and low pressure fluid leaves the turbine at its outlet at section at 2-2. So lead turbine is well insulated and hence there will no heat energy interaction between system and surrounding, and therefore we can say that Q is equal to 0. When fluid flows through a turbine, change in kinetic energy could be assumed as 0 as velocity of fluid flow will be small, and we can neglect that small change in kinetic energy of the fluid. We have also assumed here that change in potential energy is 0. We have taken work energy as positive because turbine is producing the work energy and this work is being done over the surrounding by the system. Therefore, according to the sign convention for heat and work transfer in thermodynamic system, work energy will be positive. We can also say that work energy produced by the turbine during the process will be the result of a drop in enthalpy. So for the next slide. A turbine is a device with rows of blades and mount on a shaft which could be rotated about its axis. In some water turbines used in hydroelectric power stations, water at high velocity is directed at the blades of the turbine to set the turbine shaft in rotation. The work delivered by the rotating shaft drives an electric generator to produce electrical energy. In steam turbines, steam at high pressure and temperature enters a turbine, set the turbine shaft in rotation, and lift at low pressure and temperature. In gas turbines, gases product of combustion at high pressure and temperature set the turbine shaft in rotation. The rotating shaft of a turbine is not always used for electrical power. It is also an essential part of a jet engine in an aircraft which generates the thrust required to propel the aircraft. Since the fluid flowing through a turbine usually experience negligible change in elevation, the potential energy term is neglected. The schematic of a turbine is shown in a figure. The fluid velocities encountered in most turbines are large, and the fluid experiences a significant change in its kinetic energy. However, if this change is small compared to the change in enthalpy, then the change in kinetic energy may be neglected, which clearly shows that the shaft work delivered by an adiabatic turbine is derived from the enthalpy loss by the fluid flowing through the turbine. For the next slide. A turbine is a rotary steady flow machine whose purpose is the production of shaft power at the expense of the pressure of the working fluid. Two general classes of turbines are steam and gas turbines, depending on the working substance used. Usually, change in potential energy are negligible as is the inlet kinetic energy. Often, the exit kinetic energy is neglected if in a problem the flow velocities are specified. The kinetic energy term should be included. Normally, the process in the turbine is adiabatic and the work output reduced to decrease in enthalpy from the inlet to exit state. Next slide. In steam, gas or hydroelectric power plants, the device that drives the electric generator is the turbine. A turbine is a device in which work is developed as a result of a gas or liquid passing through a set of blades. The blades which are attached to the shaft force the shaft to rotate. The work is positive since it is done by the fluid. Compressors are devices which raise the pressure of the gas that pass through them. In pumps, the working fluid is a liquid instead of a gas. Work is supplied to this device through a rotating shaft from an external source. Slide. There are several common assumptions that are made in the energy analysis of turbines. The first one is if there is no intentional cooling, the heat transfer for these devices is small relative to the shaft work. The second one is the work term is important for all these devices. For turbines, it is the power output. For compressor or pumps, it is the power input. The third one is the fluid velocities in turbines are high and fluid experience a significant change in kinetic energy. However, it is small relative to the change of enthalpy. The velocities involved in compressor and pumps are too low to cause any significant change in kinetic energy. And the last one is the potential energy change of the fluid passing through turbines, compressor, and pumps are small and are neglected. I think that's all from me, and I will pass to the next presenter, which is Mr. Megat. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muga Faiz bin Magazini from 5X BMG3. So today I will continue for my part, which is steady flow engineering device turbine in turbine. Okay, what we will cover in this chapter, in this presentation. Okay, we will cover three subtopic, which is equation, the how to conserve this energy, and then what the energy can give impact to the environment. Okay. For the first one is equation. This is the equation for energy balance for turbine. We can see at the right side, the longest one. Okay. So in general, Q is in 0. Most likely Q is in 0. Okay. We will cross the Q, and then for the V, there is mostly there is no increase or decrease in fluid. So we will consider the change of kinetic energy, and potential energy is 0. Okay, when we cancel those two, we will get the short of formula, which is m dot bracket h2 minus h1. Okay, 2 is considered outlet and 1 is inlet. Mostly work in is in positive and work out is in negative. Okay, this is some example of the calculation for turbine. Okay, for the second subtopic I will cover is how to conserve the energy of turbine. First one is keep it clean. Turbine oil cleanliness is key to ensuring the longest equipment and lubricant life. Contamination may result in formation of deposit and varnish, which can significantly reduce the life of bearing and gears, affect servo valve operation, and promote system forming. Okay, we know that oil, the color of oil is like gel. So when we did not clean the oil and the oil become dark, it will damage or not damage. The oil cannot perform well to the bearing and to the gears. So if it cannot function well, so the all around system cannot function well too. Okay, and it will also can affect some of valve and other part. Yes. Okay, next is watch out of water. If water cannot separate from the oil, free water or an oil in water emulsion is created and may interfere with the oil film needed to support the load carried by the bearing. Okay, if we did not separate the water from the oil cannot perform well, because we know that mostly bearing and gears will cover up with oil. So when we did not, so there is water in that oil, the oil cannot function well. Okay, cannot give support to the bearing. We know that the function of oil is to give support, to reduce vibration to the bearing. So if there is water, it cannot perform well. Okay, because water can promote rust and corrosion, can speed up the rate of oil oxidation, and promote others degradation process such as hydrolysis. So when we did not separate the oil carefully, it will easily speed up, okay, to make the metal rust. Okay. For the third subtopic, which is did turbine have an impact on environment, economy, and human health? Okay. For the first one is environmentally friendly. We know yet other benefit of turbine power plant is the fact that they are environmentally, not only do they run on natural gas, but unlike external combustion engine, they produce less exhaust gas pollution. Okay, in fact, turbine use the excess air for combustion. Okay, that is most likely this is the environmentally friendly, and we know that before this we use piston instead of turbine. So when we have turbine, it will for time to time turbine if is good compared to the piston. Okay, for the second one, what the impact turbine can give is cause noise. We know that turbine if gives such as a high pitching noise to the surrounding. Like when we start up the engine, if if anyone did not wearing their earmuff, they can damage their ear. Okay, uh, because to create the rotary motion, the turbine has to heat the mixture of the air and fuel to very high temperature. Okay, this is a very common impact of turbine, that is create noise. So this is one of the disadvantage of using turbine. We need to use earmuff to protect our ear. Okay, for the last one is changes. What is give impact to the economy is the changes of on aviation. We know that before this on the last before the before 10-20 years later, 100 years, we use most likely use piston. There is no turbine. Okay, so when we use turbine, it is a give use a small part but give extremely powerful performance uh, compared to the piston. Okay, so this is the like the new generation of the engine we use turbine. So when we did not know the others time 10 years later or 20 years later what we use. So for this year, for our era, turbine is the best. Okay, most likely aircraft turbine is okay for most aircraft. Don't compare to the turbojet like that. Okay. Okay, that's all from us from group turbine. Steady flow engineering device for turbine. Group 3, I guess. Okay, in 5x BME3. That's all from us. Thank you.